Just a quick video talking a bit more, follow on from my previous video, which was looking at the not so simple Fuzzface circuit, and I'm trying to do a bit of a live demo, guitar in hand, and I'm particularly want to talk about the action of this resistor here, which is a feedback resistor, but it does many things, so that's what I'm going to dig into, because I've heard various thoughts on this, and this is my take on it. Okay, so this is the basic Fuzzface circuit. I go into more detail in my previous video. So you've got Q, transistor 1, first stage, gain stage, into transistor 2. Now this is the bit area I'm interested in. So the emitter, the out signal comes out the top end. That's where your output is. The emitter, this is deals with the biasing and therefore the gain of this second stage. This emitter point here goes through a 1K resistor to ground. That's controls its biasing point. But you'll notice you've got your attack control, and you have a capacitor here to ground. When the attack is fully up, that capacitor is basically joined to this point here. What this does is the AC signal, the audio varying signal, rather than the static DC voltage level, sinks pretty much straight to ground through that capacitor. And what that does, it relieves an effect where a negative gain is produced at this point by the fact that the bias is shuffled about a bit by your input signal and the output signal and the voltage of the biasing resistor here. So as the output voltage varies on this resistor, it produces a voltage at this point which varies, which changes the voltage across BE, which gives you a source of negative feedback. If you dump this negative feedback, which restricts your gain, suddenly you get a big boost, and I'll maybe give you a quick demo of that. But if you've got a Fuzzface and an attack control, that's what we're talking about, that's what it's doing. The other thing I'm interested in is that this point is feeding, this is negative feedback, so this point, this emitter here is in anti-phase to this point here, the base of your input transistor. So you've got a 100K resistor here to take just a small portion of that output and feed it back into your base of your input in anti-phase. And what this does is it cancels out a small portion of your input signal. Why would you want to do that? It reduces your gain. Why would you want to do that? Well, it decreases the reliance on the gain of these two resistors, which can be variable gain. Rocknoll germaniums, they can vary wildly in their gains, and changing the structure around it can reduce your reliance on the gains of those individual transistors. So that's a good thing. It also increases your frequency bandwidth of the overall device, and it also changes your input impedance, increasing it for the better. So that's why it's done. But also that's the AC alternating audio signal goes back there and cancels out. But because the voltage at the top of this resistor is somewhere between 0.5 and 1 volt roughly. That you've got a DC voltage there. That some of that DC voltage is fed to your base of your input as well, assisting with the bias of that transistor, because you'll notice there's no bias voltage applied to that input. On a range master circuit type thing, you have a standard resistor to ground and a resistor up to the voltage rail, and the base is held at the balance of those two resistors. There is none of that type arrangement for this, so it's reliant on some leakage of these dodgy old germaniums, as we said. It requires a little bit of leakage and also this feedback path, and I'll try and show you that. I've set up my little pedal board, breadboard, with this old transistor, which it's actually got very low leakage, so it doesn't bias very well, but there is a point to that, so it's quite spitty. It's quite on the edge of the bias there, and I've had to bump. I've got two resistors in here in series to give me. Normally you just have 33 K resistor, but I've had to bump it up by a 47K, so we're up to 80K there to get it to bias, because the leakage is so small on this transistor. So it's not one I would normally select, but there is a reason for this. I'll show you. So you could go higher on trying to bias this up with these resistors, but it really affects the gain of the two stages and the bias of the second stage, but that's for another day. But what I wanted to show is, first of all, this 100K feedback. I've got on this pot, which is 100K, and it comes through this lead into the base of the transistor there. This is Q1, this is Q2. And if we pull that out, the bias just goes to pot. So the action of that feedback is helping to pull that transistor into bias, that feedback. So there's a DC element to that feedback as well as the AC. Right, so if I now reduce this pot, just to show you, if I back off the volume, we get nothing much. It just dies out really. Right. Now, if I start changing this feedback, we're changing the DC element, going to that transistor, and suddenly the bias swings right in. It swings back into play. So it's really helping the bias there. But if I go too far, what's happening now is the AC part is rushing down through, so this 100K now is probably down about 5K or something like that, and the AC is rushing through there and cancelling out my input, and we get virtually nothing now. Increase the resistance a bit, and we got it roaring back to life. Now if we roll off the volume now. You get a nice clean up like you'd hope from a Strat into a Fuzzface. So that's just showing there's AC and DC stuff going on in that feedback resistor. The other feedback we talked about is our attack control, and basically dumping AC through here. So let's try and explain this. So the ratio of this resistor to this resistor basically is the outside controller of the gain of this stage, and as this resistor tends towards 0, so you get 8k over 0, the gain increases. So we need this 1k for the biasing of this point and this point, but if you dump the AC from this emitter point through this resistor to earth, it's as if there is no resistance for the AC signal, so you get maximum gain on your AC. So if we take away, so this is turning, I've just taken out that bypass cap. Basically it's like turning your attack pot down to 0, so exactly what you'd expect. Plug it back in. And basically that's changing the gain of the AC portion of that second stage transistor, leaving the DC as it was. I hope that helps. I hope that's been of interest. Bit of a wander through the feedback, a bit of a demo of the feedback elements of the circuit. If you've got questions, stick them in the comments below and I shall try and answer you. And please do play the other video. I'll go in a bit more into depth into the other bits of the circuit, but this is just trying to do a bit more of a live demo of it. Alright, thank you for your interest and dropping in, and hope to see you again. Cheers, thank you.